Good afternoon, ladies and gentlemen, dear colleagues. Thank you for joining us on day 4, the final day of our training session. I'm really happy to see you all, although online, but still it's really encouraging. And thank you for making it to our final day. We have a huge plan for today. So Saida and I have been talking about different aspects of using Scopus for staying updated on what's going on in your area and looking for the most impactful papers and taking care of your own profile, understanding metrics, looking for journals, and many, many other things. So today we're gonna build upon this knowledge with some advanced approaches, metrics, functions offered by Scopus and beyond staying for some of the solutions which might be available to you or might not be, or somehow in a limited capacity. In any case, we're more than happy to consult you on the availability of those functions. But first things first, let me just quickly guide you through our plan for the next hour. So first, we're gonna get back to Scopus and talk a little bit about the most advanced approaches to specifying the papers that are really fitting your academic interest with ASJC subcategories and some advanced commands, some of which, by the way, we have already discussed a couple of days ago. Next, we're gonna stay in Scopus and talk a little bit about more things that we can discover about a particular article, specifically about some impactful articles that are really interesting to you and fit to your academic interests, and how you can build your understanding of the research landscape of what's going on in the area of your interest using those most impactful, most important publications. We'll do that in Scopus and then take a step further and take a sneak peek into SciVal, our analytical system, which is, among other things, designed for analyzing academic landscape. As a next step, we will take some terms from the topics that we discover with Scopus and SciVal and try to employ them in grant search. We'll do something that we have tried during our earlier trainings in Scopus, and we'll do the same thing using Funding Institutional, another special analytical solution, this one specifically designed for grant search and analysis. We will, as a next step, look into research data, something that is fueling quantitative research nowadays with its importance only increasing year over year. We'll have a look at a specific type of publication, a data paper, and how to discover those in Scopus. And again, we'll take a step forward and have a look at a special search engine we've designed for research data discovery, that is Data Monitor. Next step, probably the most advanced thing that we're gonna talk about today is our APIs or application programming interface. So APIs are essentially a set of tools or a specific language that helps you do whatever you want, basically with our data, and access any data you need on a regular basis. And that is particularly useful for some big analytical or research projects, or for performing repetitive tasks, such as, for instance, getting some recent paper data on a monthly or weekly basis. We'll take a look into that, and I will share some easy steps if you have never coded, on how to start working with API and write your first script. Finally, as a bonus, we'll once again touch upon the new hot topic of Scopus AI, our generative AI based on a large language model, and we will play a little bit with its current version available. Okay, so we've done with the plan and already spent a few minutes discussing it. So without further ado, I will just make another disclaimer and we proceed to the actual content. So this is just a reminder of the databases and solutions that you definitely have access to as part of the National Consortium subscription, or and those solutions that you might have access to on an institutional basis, or might not. If you have some doubts whether this or that solution is available to you as a faculty member of your institution, you can talk to your TTO officers, or librarians, or research management team, or just ask us. And in case those solutions are not available, we of course are happy to talk on how to provide that particular solution to you and your colleagues. Now, to the first topic, we're going to talk about the most advanced approaches to discover the most relevant papers in Scopus. First of all, something that we have already discussed, phrases and standalone words, and how to treat them in your query. So by default, as a reminder, when you are using Scopus basic search, all the terms that you type there are treated as if they are connected with the operator and, this logical multiplication. That means that all of the terms that you're typing by default need to appear either in the title, or in the keyword section, or in the abstract. However, they can appear in different parts, such as, for instance, if you are typing network analysis in basic search, the word or the term network might be present in the keywords, and the word analysis might be present in the abstract, and the entire paper might not be about network analysis or network science, but might be related to neural networks. So in order to avoid that, if you want to address some multi-word terms, such as Zika virus, or a railroad transportation, or something else, something that contains 2 or more words, you need to use quotes or curly brackets. The difference between them will be explained just in a minute. And again, for the basic search, the default combination of fields is titles, abstracts, and keywords. If you need to address some other fields, or a combination of those, you will need to use advanced search. But basically, if you're looking for the papers using keywords, these three areas are something that contain relevant information relevant to the actual content of the paper. More advanced knowledge on how Scopus search works. Some things Scopus is doing in the background to make your life easier and to return more results that might be relevant to your query. So, for instance, Scopus will replace all the special symbols or all the characters with diacritics, such as accent or an umlaut or others, with its regular analog in the Latin alphabet. So, for instance, as you can see on the screen, the example of an author's last name will be replaced with its equivalent, but without any diacritics. And it also doesn't matter if you are using uppercase or lowercase characters. Just all of them will be, all the possible combinations will be considered while the search is performed. Another thing is lemmatization. Scopus will try to look for all the possible forms of a word that you are querying, such as, for instance, if you're looking for a bacteria, for bacteria, it will also use the singular form bacterium. Or if you're looking for, I don't know, a virus, it will also include all the papers that contain the plural viruses. And the same is true for other parts of speech. Also, Scopus will drop all the so-called stop words or insignificant words, such as articles and conjunctions and pronouns, and that is done again automatically. It might be a little bit tricky if some of the terms that you're looking for are the same as in their abbreviation as the stop words. We can think of a couple of examples, even using those which are on the screen. For instance, if you're looking for some papers in the field of information technology, or in short, IT, you will need to specify that IT is a term and not it, a stop word, which will be excluded automatically. The same is true for instance, the, which might mean THE times higher education. One more thing that Scopus does for you is replacing some terms such as, well, the Greek alphabet and their equivalent Latin spelling, or British and American variants of spelling some terms. Finally, if you want to stop Scopus from doing that, and for instance, you want to treat it as IT, information technology, and not a stop word, which will be excluded, you need to put those words or terms into curly brackets. Those brackets will cancel all these automatic background procedures. Some more advanced operators, preceding and within. If we have a few words which are connected with each other, if we have a multiple word term, but it might so happen that the could be a few terms that appear between them. We want somehow to address that. As you see in the example, we might be looking for Zika virus papers, but there are a lot of publications out there that address these two similarly distributed viruses, Zika and dengue, and many papers address both of them together. So we might want to say, to explain to Scopus that we want to look for the term Zika virus, but there could be two words appearing between them. Therefore, we can use the command preceding PRE, then a / and the number of words that can appear between our terms. Within a W, then / and N works similarly, but there is no order. The first term might appear first or might appear last, so they can be interchangeable. I believe the examples on the screen are quite self-explanatory. Next thing, I think we have that already, have discussed that already, but it never hurts to remind. We have two types of wildcards. Wildcards are those special symbols that can be replaced with any character. So the question mark means that Scopus will replace it with exactly one character, and asterisk represents any number of characters, including 0. So again, as a reminder, if you want to cover all the words, all the terms that starts with the word transport, like transportation or transporting, you write transport and then asterisk. Next thing that I wanted to touch upon before switching to Scopus interface for a while is search with subject fields. As you probably remember, we can address ASJC subject fields with the query clause that sounds as subj area. And then there is a designated code for each of the broad categories that are present on the ASJC list. Those can be chemical engineering or earth and planetary science or physical sciences, social sciences, and so on. So there are a total of 27 broad categories like that. What if we want to address a narrow category or a subcategory that these broad categories break down into? There is another command for that. It is called subj main, and to use it, you need to have a look at the list of all the ASJC subject areas. Let me switch for a couple of minutes to Scopus and its interface and show how that is done. Okay, so we are on the home screen of Scopus again. And first, to see the list of all the subject areas, we need to go to the sources page and download this list of all the Scopus sources ever indexed. I won't do that now because that's quite a heavy file. I have it already at hand, and I will switch to it and show where to find that useful table. So you'll have all these tabs with all the sources ever indexed, recently accepted titles, discontinued titles, and so on and so forth. The very last tab contains the detailed breakdown of all the ASJC categories. The green ones are broad categories or just categories, and the white ones are subcategories, which we need for a detailed query that we're talking about. So for instance, if I'm interested in, let's say, some area of engineering, for example, safety, risk, reliability, and quality journals, I will need to copy or just memorize this 4-digit code 2213 and use it in my Scopus query. So we're looking for very, very specific journals on safety, risk, reliability, and quality. And we go back to Scopus interface. Back to front page. And we go straight to advanced search. Let me remove this. Instead of subject area, we use subject main and then type 2213, closing bracket, and we'll get all the papers in this very specific subject area, subcategory. Now, if we want to enrich our query with something else, we can do that with a logical operator and another clause, for instance, looking for some keywords among titles, abstracts, and keys, and well, the keyword section. Let me look for something. So it's safety, it's something with engineering. Let's talk about extraction of fossil fuels and drilling rigs. So I'm putting this in quotation marks for these two terms to come together, right, one after another. If I want them to be able to be separated by a few terms between them, let's put this // and 2. So there might be two terms coming between drilling and rig. And we have a very specific selection of papers related to these devices for extracting oil and appearing in the journals focusing on risk and safety issues. Now, if we can sort them, for instance, by citation, we'll get the most impactful, the most important papers come first. Let us get back for a second to my slides, and we'll proceed from here from areas and these advanced search queries to focusing on a specific article and understanding its broader context. go. By the way, another remark regarding keyword search. If you are struggling to find some specific terms that are related to your broad area of interest, you might considering using ScienceDirect topics for help. If you enter some broad area, you might get useful hints of how that broad term appears in different contexts. And all these terms are derived from academic literature that we have on ScienceDirect. So that means that these are widely accepted, widely used terms, and you will definitely come across a lot of search results if you use them in Scopus. So sciencedirect.com/topics might be a useful, helpful tool for finding the right keywords for literature search. Now we proceed to article level analysis. And here we have a typical front page of an article that you come across once you click on your search results. This is a really impactful article, and it is, we understand that by looking at the three major article level metrics: number of citations, FWCI, and number of views. So the number of citations is pretty straightforward. It's just the number of papers indexed in Scopus that are citing this particular article. Number of views is a little bit trickier. That is a metric derived from the statistics we have regarding the activity of Scopus users. So it's the number of times that a Scopus user has, Scopus users either opened this page of the article or used the link to the publisher's website to claim the full text. Of course, we are removing duplicates or attempts to somehow inflate this metric, but other than that, this is a useful additional source of information and particularly a way to understand if an article is worth reading in case it hasn't been cited yet. That can be true for recent articles that appeared this year or last year, and their citation rate might be low for that obvious reason, but their views count might be high, which tells you that this article is already popular with your research community. Now we pass on to FWCI, the metric which is a bit complicated in its calculation, but pretty straightforward in understanding. So this metric illustrates how the number of citations of an article compares with similar articles. And similar articles means articles of the same type, same year, and same subject category. On the right, you see a screenshot of the page from our metrics guidebook, which I recommended on day 2, I believe. This illustrates in particular how we are calculating FWCI for single papers and for a few papers for if we are assessing an author or an institution or a country. And you can see that for articles that appear in multidisciplinary journals like Publication 2, in a journal in immunology and parasitology, we are comparing this article with both of the areas, and then we're calculating on step 3 the harmonic mean. and get some results. In general, this metric illustrates whether the article or an entity, such as author profile or a country or an institution, are cited higher or lower than the world average, accounting for the differences between years, disciplines, and types of publications. So if we get back to the previous screen, we can see that this article is outstanding. It is cited 24.39 times more often than similar publications. That is, publications of type article published in a year. Well, we don't have the year here, but I guess it must be quite a recent one, and published in transportation journals. More to that, if we scroll down and look at the article details, there is a section related to PLUM-X metrics. Those are metrics which illustrate an article's wider impact, you can say societal impact. Among other things, there is a section related to the article's appearance in mass media, and that could be an additional source of information, particularly if you are doing applied research, such as this article related to cargo transportation and port logistics is appearing in a news posting in a Railway Age magazine, and a news outlet which might be interesting for you if you're doing research in that field. But for any article with a number of citations like that, you may come across more news postings, which will lead you to some interesting alternative sources of information. And next thing, before switching to the Scopus interface, is SciVal topics. And I think we have talked about that a little bit already, but I'll repeat maybe that a SciVal topic, or just a topic, is a cluster of publications that are very densely connected to each other with citations. So we have, let's say, 100 publications, and many of them are linked to each other. But then if we look at the connections of this block of publications with the rest of Scopus, there are only single citations. So our clustering algorithm understands that, and at a certain cutoff selects that block of publications as a cluster and calls it a topic. Normally, such kinds of publication groups would be related to the same topic or very closely related topics with the same set of keywords, with the same common research interest, objects, or methodology, and so on. So that article that appeared on the previous screen is part of the topic named Container Ports, Short Sea Shipping, and Harbors or Waterways. Those are the three keywords that appear in this cluster of publications most often. And the number 99.091 illustrates that this topic is highly prominent, that it is growing, that it is well cited and well read in the recent 2 years. Now let me switch back to Scopus and show how we can do that And maybe we'll proceed to the next topic too, using the interface. Okay, so we have some highly cited article here, and if we scroll down, we'll see its topic data. Well, this is a recent article, so it hasn't been assigned a topic yet. So let us get back to search, and we were looking for ports and harbors. So let's try this combination of terms. And let's say we'll be looking for a subject, narrow subject area 2213, which stands for transportation. We'll have this selection of papers. Let's narrow down our search to recent papers only. And let's get the most cited publications first. Well, let's pick some of these, maybe the top one. And have a look at its topics and alternative metrics. Alternative metrics will appear here in the bottom. We see that it's still a highly cited one, 4.72 times more often than the world average. We have some plum metrics for it. But no news postings. Oh yeah, there we go. This is the article that is from my presentation. So we have some recent news and a button to discover more news postings. And if we get back to Scopus, we'll have this SciVal topics section. If we click on its title, we get this pop-up window with the most representative documents, which means they are both very similar to the article that we discovered, and they are highly cited. So these are articles worth your attention, most probably. And if you want to discover more, you can have a look at the keywords here. And these keywords can be used for further search as a combination, and you can also sort them by relevance. So you'll have the most frequently appearing one in the top of the table. Also, these topic areas can be discovered in SciVal. If we get back to, if we go to that solution, we will use the same name and the same topic attribution as we would for Scopus. So for that, we need to open topics, copy and paste those keywords, maybe delete some of them, container port. There we go. Or maybe it's not that one. Yes, this one, container port, short sea shipping, harbors, etc. This will offer you extra knowledge about the journals that are most prominent in this specific narrow area here, and which journals are worthwhile publishing in using this citation metric, because you can see that Journal of Coastal Research has a lot of articles about ports and port logistics and so on, but is not very well cited in this particular narrow area, whereas Maritime Economics and Logistics would be a good choice. Then we can discover our potential co-authors or colleagues or reviewers who again are the top researchers in this narrow area, and discover more about how this topic has been developing over time. Now, we can use those terms for discovering grants. Scopus offers you an opportunity, as we have seen earlier, to discover historical grant information. So let's do that and try, let's say, maybe a little bit broader a selection of terms. Let's say we are interested in cargo transportation, so we'll put cargo, or cargo, sorry for a typo, or freight, because we have freight transport and cargo transport, and that's pretty much the same. Then we add and we will need to add some funding query. As you remember, we cannot leave it empty, so we'll need some generic, I will explain it in a second what I'm doing. We'll need some generic content to fill this funding data area in art or study, or let's say. So if a word, article, or study, or research, or any of their variations appear in the funding section, and normally they appear, such as in a phrase, this article has been sponsored by so-and-so, we will get those sponsored articles with the funding details. Click search, and we get all those transport-related articles listed by their recency. So we get this article by a collaboration of researchers from China and Taiwan, and from China and Taiwan. And we go down to funding details. Here we can see all of these funding sources, and some of them are active links, and those active links lead us to our next solution that we're going to quickly touch upon, and that is Funding Institutional, a search engine for discovering grant opportunities. So if we click here, we just get to the funding organization here. But of course, we can just search for grants using simple combination of keywords like this. So we get this selection of actively available opportunities that we can apply for right now. But if we want to get properly prepared for our grant application, we also might want to go to historical data, awarded grants, and again, click, select some keywords, and see, well, that, a lot of cargo transport research has been funded in recent years. And we can also get, instead of the chart view, the list of all the grants and see the details or what kind of research was sponsored and who were the receiving authors and institutions, and most of the times there would be some active links leading us to the initial grant institution to discover. So this is what we can do with grant analytics. Now for the next topic, we have a research data search, and we go back to Scopus and its front page. Let's say we are looking for, give me a second. I need to say a few words about what kind of papers we're talking now, and I'm getting back to my slides. There we go. I will skip this part and we go directly to research data discovery. So all the things that we've done in the Scopus interface will be in the slides, so you'll be able to review these functions and workflows. Now we are passing on to the next advanced search scenario, that is research data discovery. And one of the options that you have in Scopus for that, apart from using keywords such as dataset or a database, is looking for a particular type of a publication, and that is a data paper. The data paper is a type of publication similar to an article, but it focuses primarily on carefully curated data describing the methodology for data collection, the purposes of those data, and their potential use scenarios. This is a comparatively recent type of a publication, but there are already thousands of them in most of the research areas. And when you come across a data paper, you may rest assured that these data are most suitable for your data-driven quantitative research that can be potentially reproduced and therefore would be more trustworthy within the research community. So that such papers are both worth being read and then used for your own hypothesis check and quantitative study, as well as worth being written itself, because when you share a high quality data set or database that is accompanied with detailed descriptions, you are inspiring many more researchers to avail at your knowledge and your collected data to come up with their own research ideas and publishing their traditional experimental papers, normally of type article. So to do that search in Scopus, we need to run a simple command that is just document type and DP in brackets, and we'll get around 13 publications by now, and that number is only growing. And most of them are very recent, just because this type of publication is quite new. We can also combine that type of a query with a request to limit our search by a subject area or by a keyword search, such as on the left, SME, standing for small and medium enterprises. Another option is in SciVal, and we have a special curated publication set or publication area, which includes papers indexed by Data Monitor, another solution of ours, a special search engine designed this time for of course, discovering data sets and other types of research data. I'm switching to that solution in a second. So there we go. Let me start from the beginning. The interface is pretty straightforward, and all these solutions are interoperable. So for instance, if you want to discover data related to your institution, you can use Scopus institution ID to do that. And we get this selection of papers, but these are papers associated with our company, Elsevier. We can also do a regular keyword search like this. All and medium enterprise, and we will get a lot of economics data. There we go. And most of these data sets would be really new, 2022, 2021, and just as in Scopus or similar to Scopus, we can narrow down our search by subject year or type of data or type of data repository and so on. Okay, we are getting closer to the end, and now we have the most advanced part of our webinar, that is APIs. So an API is, or application programming interface, is essentially a language. Oh, sorry for this. Let me get back to this slide. Yeah. So is essentially a toolkit or a special language that helps you use functions of any piece of software. Well, most of them, most of the web services and software that you come across on the net will have their API toolkit. Same is true for our products, including Scopus, which has quite a diverse family of different APIs. First, maybe why would you need using API if you have never done that, maybe with some other solutions before? It is useful for performing tasks on a regular basis, something that you can scale, something that you need to be done every week or every month, and you can code that cycle and have it done within just a click of your mouse, or even without that. That could be, for instance, collecting data regarding your institution's research or research of an area of your interest, and then saving in your repository, or doing an analytical project or a study in the field of scientometrics. So whenever you need to collect a lot of diverse data using some complicated parameters, you might consider using API, because that is essentially the same data that you can find in Scopus using advanced or basic search, but with more flexibility and with that workflow. If you have set it up once, you won't have to repeat the same work manually again. Accessing Scopus APIs is part of your subscription, and now that you are part of, your institutions are part of the national consortium, you don't have to do anything but to go to our developers portal, dev.elsevier.com, and claiming your API key. You just log in with the same email and password that you use to log in Scopus or Science Direct or other Elsevier solutions, and then you create your API key. Label is just something that you will recognize your key with. For instance, you have your scientometrics project, and that will be like my scientometrics key. And then you have your key for updating your website, and that will be my website key. Normally, it's a good practice to have one key per specific task, and you can generate up to 10 keys for your user account. And then for website URL, put the website of your university. Then the next thing would be to look through our terms and conditions. And well, the general idea is that APIs are free for non-commercial use, for academic use. And if you see that your use case is different from those described in the terms and conditions, you need to post a request to API support at elsevier.com. Also, if you want to use APIs outside of your institutional network, outside of your IP range, you need to send that application as well to get a institutional token. It's like something that accompanies your key and gives you extra rights in that case, well, to connect to APIs outside of your institutional networks. It's also an option to just drop an email to Saide or me, and we'll help you to set up your institutional token as well. It's just necessary to describe the purpose for which you are using your APIs when you are sending such a request. So for use cases, just as I already said, please check if your use case is compliant with any of the standard use cases that we have on our website. And apart from Scopus, we have a lot of other APIs for the rest of our products. Now, some of the APIs might be disabled, and again, you need to send an email to API support@elsevier.com to activate them. By default, for instance, the citation overview API will be disabled. And here are some other cases where you might contact support, for instance, to increase your usage quotas. Now, there is a special page for you to start practicing with APIs on this developers portal. That is interactive APIs page. We have all the APIs listed there, and without a line of code, you can just start experimenting with different types of them and see what kind of response is there, and also get a correct URL for your request. So here, for instance, I'm looking for a set of documents associated with one institution with Scopus Search API and related to a particular subject area, mathematics. And on the right, I can see, well, what kind of output that API with that request gives to me. Different APIs have different quotas, and if you need them to get extended, well, post a ticket to the support team. Now, your a response to your query will contain some extra helpful data, for instance, your remaining limit for this week and your time until this will be updated. Time in the unique time step format, which can be simply converted into month, day, and year format. One more thing that might make starting your work with APIs much easier. It's wrapper packages, something that has already put together these standard queries in a more intuitive way, depending on which programming language you are using or you are considering starting to use. There are a few options. For Python, we have ELS API, a package developed by our team, and Bibliometrics, developed independently. And for R, there is R Scopus, another package with similar functionality, but for a different programming environment. I have put here some examples of how APIs can be used to solve some simple tasks to start practicing with. For instance, getting some metadata of a publication and seeing how many citations and authors it has, or visualizing some data, for instance, how many authors affiliated with this or that country contributed to a particular area. And all those examples are on my GitHub page. And if you want to start practicing, that could be one of the easiest way. Just download one of the scripts, copy and paste it in the programming environment you're using, and just replace the variable which stands for API key and institutional token with your own ones, and just see the magic. Now we're passing on to Scopus AI. I hope we still have time. Yeah, I think we do. I have some slides here, but I guess we'll leave those and pass on straight to playing with this new solution. I'll just switch to the interface. There we go. So far, Scopus AI is in its alpha testing phase, and we have a very limited number of users taking part in it. But our plan is to release the marketable version in January next year, and we'll keep you updated on how that will be introduced, particularly in Turkey, and on its availability for the Turkish research community. So far, I just wanted to share a few examples, and if you would be interested after seeing this in taking part in later trials of this system, you have a link to the promotion page, and that Saide shared in one of the earlier trainings, and just share your contact details, and our colleagues will get back to you. So far, we have the following functionality. Scopus AI accepts natural language queries. There are some pre-suggested queries as well, so we can use one of these. For instance, we're building a new team, a project team, and we're interested if we should care about the personalities of them, or maybe, well, we are doing psychology research, and that is one of the research questions that we would like to address. So instead of looking for keywords such as personality, maybe accentuation, character, and creativity, and then combining them with and or, we can just ask this question using natural language and get this nice, concise summary, which says that essentially some of the character traits are positively associated with team task conflict, and that diversity can enhance team creativity. Well, diversity in terms of, again, personality, that is character. This AI is accompanied by a set of functions, one of which is suggesting additional discovery queries, which will either dive deeper into the topic or suggest some relevant topics, or discovering some interdisciplinary research. So for instance, here we get diversity of cognitive styles instead of diversity of personalities. So kind of a parallel direction of in the same field of psychology. Also, we can visualize these discovered papers as a graph, not papers, but rather the content, the key terms that appear in these papers. And most importantly, well, from my humble view, is that we can track the sources from which all these statements are coming from. Normally, with many LLMs, LLM-based artificial intelligence systems that we currently have, we cannot be sure about the source of the response. Whereas here we have direct links to Scopus papers, and these papers are more likely to appear in the summary if they are, of course, relevant to the search terms, if they are recently published, and if they are cited. So it's either a very recent paper, 2023, or a paper a bit older, but with some significant number of citations by Scopus sources. So far, we are using Scopus abstracts to generate these summaries, and their content starting 2018. I think this is it of as regards the planned content. I know this has been a lot, and I hope this has been helpful. Now we have a bit more time to address your questions. So I'm switching off screen share.